Hello everyone, welcome back. Today in this lecture in the chapter drilling machine, I'll be explaining about the various drilling operations. In previous lecture, I explained about the introduction portion, then the specification, then the various types, portable, sensitive, and the other upright drilling machine, radial drilling machine, gang drilling machine, then the turret drilling machine, deep hole drilling machine, then the multi-spindle and automatic drilling machine. Now in today's lecture, I will explain about the various drilling operations. So in briefly saying, there are the total number of operations is around 8 to 9 operations are there in the drilling machine, and the first operation is the normal, we can say, the drilling. Then another things we can do with the drilling machine is to reaming. We will see what is reaming, then boring, counter boring, counter sinking, spot facing, tapping, or trappening, then deep hole drilling. Deep hole drilling you have seen in the figure, and these other operations I will explain them one by one. So let us start. So the first operation is reaming. Here, reaming is operation of finishing an existing hole very smoothly and accurately in size. So what is reaming? Reaming is a finishing operation, which means suppose we have drilled one hole with the drilling tool. Now we want to finish the internal surface. We will use the reamer, and that will be used for accurating the size. A drill will not produce a hole having sufficiently good quality of finish and accuracy for many purposes. Therefore, when a very accurate or smooth hole is required, the hole is first drilled a little undersize, then it is reamed to correct size. So here, for very accurate purpose, the smooth hole is generated with little undersize, and then it is reamed to correct size. Reaming for finishing to its size, for finishing to size a drill hole. The for after finishing, the size is given to the drilled hole using the reamer. Accuracy to be expected is within the plus or minus 0.005 mm, which is 5 micron. Up to 5 micron accuracy can be achieved. A reamer is a multi-tool cutter which rotates and moves linearly into an already existing hole. The previous operation could be drilling or preferably boring. The reaming provides a smooth surface as well as close tolerance to diameter of hole. Generally, the reamer follows the already existing hole and therefore will not be able to correct the hole misalignment. Here, what happens? The drilling reaming operation can be preferably used only after the drilling or boring operation, preferably boring. After boring, the finishing is mostly required. Sometimes after drilling, it might not be necessary because you can see the rim geometry is somewhere nearer to the drill. It is having the straight fluids, and the reamers are usually follows the existing hole. So if the already done hole is misaligned, then there are chances that the reamer will also follow the same path, and that misalignment cannot be eliminated. Next is the boring operation. It is an operation of enlarging an existing hole. As you have seen, the single point cutting tool is used to reduce the diameter of the workpiece with a Now, similarly, in boring tool, there is one shaft and one point cutting edge is mounted over here, or bit, or we can say the tool bit is mounted over here, and that is our boring tool. So that boring tool will be feed and the workpiece will be rotated. So we will get the enlarged hole over here. So in a boring operation for enlarging an existing hole, for that we have to require one first drilled hole, then we can enlarge that hole with the boring tool. When a suitable size of drill is not available, initially a hole is drilled to nearest size, and using a single point cutting tool, the size of hole is increased by lowering the tool while it is continuously rotating. The size of hole is increased to its entire depth. So here, by lowering the tool while it's continuously rotating, the size of hole is increased to its entire length. So for enlarging, when the drill size is not available, suppose we want diameter 50 diameter, so drill of that size might not be available. So instead of using that, we will use the boring tool, and the boring tool can successfully drill that size of hole with this single point cutting tool type of arrangement. Another operation is the counter boring. Similar to boring, in boring there was only one single point cutting tool. Now in counter boring, this is like a drill, but it is having the flat end. The end portion is the flat, and you can see there is one pilot that is used to guide through the hole. That the this counter bore does not go away from the, that will follow the or stick to the drilled hole. First we require to drill a hole, then we will use this counter bore tool or the counter bore tool, and the operation of enlarging the drilled hole. This is also the operation of enlarging drilled hole. That wise it is a boring operation, but here it is the counter boring. It is a flat faced, and here the counter boring forms a large size recess or a shoulder to existing hole. For example, you want to fix a bolt in this hole, so the bolt head will be resting in this position. So for bolt head to fix over here inside this portion, the counter boring tool can be used. Cylindrical tool will have a small cylindrical project known as a pilot to guide the tool while the counter boring. So the diameter of the pilot will always be equal to the diameter of the previously drilled hole, and the interchangeability pilot of different diameter are also used for counter boring hole of different diameter. The speed for counter boring must be two-thirds of the drilling speed of corresponding size of drill hole. The speed is generally of the counter boring is kept very low. Then there is the counter sinking operation. It is the operation of forming a conical shape. Same in the counter boring, we used to generate a flat shape. Now we want to fit a screw. Okay, so the countersink will tool will be used. It is having the conical shape at the end of a drill, and it is done using a countersinking tool. The cutting speed for countersinking must be about one half of the used for similar size drill. Okay, the countersinking hole are usually used when the countersunk screw are to be screwed into the hole, so that their top face have to be flush with top surface of the workpiece. The countersinking process may be employed for deburring the hole. So this is about the countersinking operation. Next operation is the spot facing. Here you can see there is one the flat space or the flat smoothing disc which is used to smoothen this top edge. Suppose we want to fix a nut bolt or the washer over here perfectly, and these edges are suppose rough. So for perfect or tight fitting, the spot spacing operation will be used. Is a smoothing and squaring the surface around a hole for seat for nut or head of the screw. Suppose we want a airtight joint, so or the nut and screw should fix perfectly over here. For that, or we can say that the in automobile the hole should be produced such that there will be no vibrations. So to minimize them, the nut and washer should be placed perfectly over here in the flat surface, so the spots facing operation can be used successfully over that. So spots facing may be done with a counter boring tool or using a spot facing tool, tapping. So the counter boring tool can be also used for spot spacing, or a special spacing tool like tapping for tapping can be used. Next is a tapping operation. So tapping is the operation of in which the external threads are cut in the existing hole. Here the in figure you can see the tap, or which is having the threads cut over here, is used for cutting the existing hole. The tapping tool you might have seen in the workshop, and in tapping the operation in which the external threads are cut in the existing hole. External or internal hole can be cut, and the tap is used generally for the internal hole. Here there is one mistake over here. Tapping is generally for the internal holes, and the tapping operation is used for flute threaded tool called as the tap. The tool over used here is the flute threaded tab, which is called as a tap, and a tap is a cutting tool with a thread cut accurately in its periphery. These threads are hardened and ground and act as a cutting edge. They act as a cutting edge, they are hardened and ground. The tap removes the metal when screwed into the hole and generates internal threads. The tap removes the metal when screwed into hole and generates internal thread. It is used for generating the internal thread. Suppose we want to fix a nut or bolt, we will require the tapping tool. A hole of required size in which the internal thread are to be generated in drilling using a twist drill. The drill spindle is fitted with a tap and the feeding is done by operation the feed lever similar to the conventional drilling operation. During this operation, the spindle speed should be lower than the using the conventional drilling. A hole of required size in which the internal thread are to be generated is drilled using a twist drill, and the drill spindle is fitted with a tap and feeding is done by operation feed lever similar to the conventional drilling operation, and during this the spindle speed should be much lower than the used in conventional drilling. Next is trepanning operation. Trappening is the operation of producing a hole by removing metal along the circumference of the hollow workpiece. So, a hollow cutting tool. This one is the hollow cutting tool, and these are the cutting edges. This is used for removing or creating a large size of hole. So, producing a hole by moving removing the metal along the circumference of a hollow cutting tool. In wall drilling, you might have seen sometimes for to creating a large hole, this type of tool will be used, and this operation is used for producing large holes or grooves around hole. Then the deep hole drilling, as we I have already explained about it, the rotating tool, the typically uh, non-symmetric component or round part with off-center holes. Then the cutting speed is determined by the tool spindle speed. Drill drift can be significant when the compared by to rotating workpiece or counter rotating processes. Then the rotating workpiece, typically used for round parts with a deep hole on center hole. Then the cutting speed is determined by the part balanced to allow high rotating speeds. Drill drifts is reduced compared to rotating tool, and the counter rotating tool and workpiece, ideal process for round workpiece with deep or on center hole. Then the cutting speed is determined by the combination of tool and workpiece and provides optimal hole strengthening and concentricity. Here in deep holing, these are the three types in which first one the tool is rotated, in second one the workpiece can be rotated and tool is fixed, and in third one the tool and workpiece both are rotated. So this is about the all the drilling operation. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.